saying it should show up at the top of the display.
We're going.
Good? Where's Bonnie? Bonnie's with Michelle.
You put that pressure
Now
on
you
me
have
like
to
that, man.
question Michelle. Somewhere between New Jersey and here. Some people seem to view the first day back from vacation as optional, Michelle. I don't really think that that's right, but apparently they do. Just saying. Alright, so remember, we take a little slice of this, and then you add up all of those slices, and that gives you the area. So to get the area, in order to add the slices, you're going to start at some spot A, you're going to finish at some spot B, and the length of each slice is f of x minus g of x dx. Okay, and that's how you find the area. And you just add all of them up. So we did this on Wednesday. And of course you can watch this in Miracle of Video. No YouTube channel. Actually, I think there is a YouTube channel. I think we put all these videos somehow. There's a YouTube that you can find these. But you have to have, like, privileged access. I'm not sure. Alright. Now, suppose I want to find what happens if I spin this volume around, this area around the x-axis. I get a volume. In other words, if I have some shape like this, this is the slice of the shape, and I spin it around the x-axis, I am going to get something like that. In other words, I'm going to get, a washer. Okay? Or a disc. The difference between a disc and a washer is a disc doesn't have a hole in the inside and a washer does. So I'm going to get something that looks like that. If you use your three-dimensional imagination, I'm a terrible artist. Okay? But basically, you take that slice and you spin it around. Now, why would you do that? Okay? That will give you a volume. You now have something in the shape of a disc. And then you add up a whole bunch of discs, and you'll get the volume. So if you have some region, let's just take a simple region, like something like that, and I want to find out what happens when I spin that around the x-axis. I'm going to get something that sort of looks like a lemon or a football, and I want to find the volume of it. Okay? What I can do is I can slice it, and every cross-section will be a circle. Okay? And then I add up all the circles, and that'll give me the volume. The circles are going to have different radii. Okay? It depends on where you slice. So if you slice right here, you get a big radius. And if you slice right here, you get a tiny little radius. And then when you add all of those up, you get the volume. Remember, you add up by using the integral. Okay? So what does each slice look like? Well, each slice looks something like that. Okay? If you take a very thin slice, it'll be a circle with a hole in the inside of the circle. So how do you find the area of something like this? Because that's what the cross-section is going to look like. If you could turn it sideways, you would get this circular region. Well, okay, if you call the little radius little r, and the big radius big R, then the area of this is pi big R squared minus pi little r squared, or if you factor out the pi, r squared minus r squared. Okay? So look, that looks suspiciously like this, because big R is going to be the distance from the axis to the top curve, and little r is going to be the distance from the big axis to the bottom curve. So basically, this again, except now we're spinning it, right? So we're getting a circle instead of just a line. Okay, when we add up all those circles, we get the volume. So let's do an example. It's very hard to picture this. And I put pages from my book. You guys saw the announcement yesterday? So they're up with lots of explanation and pictures and all that stuff. So if I want to find the volume, it's going to be pi big radius squared minus little radius squared from A to B. So for example, formed by y equals 9x minus x squared in the x-axis. Find the volume that results when r is revolved about the x-axis. So it's actually going to look pretty much like this picture, but I'll redraw it. So what does 9x minus x squared look like? Well, y equals 9x minus x squared is x times 9 minus x. So that's equal to 0 at 0. It's equal to 0 at 9. And it's an upside down parabola. Okay? And it's kind of your job to know how to graph something like 9x minus x squared. So I'm going to take that region and I'm going to spin it around the x-axis. Why would you want that, by the way? Because if you want to make shapes other than these simple sort of spheres and things, basically what happens is you're going to take the cross-section and add them up. If you think about a 3D printer, that's what it does. It lays out all the cross-sections and just adds them up. Okay? So when you want to make these complex volumes, like you imagine like a Coca-Cola bottle, you just have to describe the boundary of the region, and then you spin it around, and now you have the volume of the region. Okay? If you've ever used a lathe in shop, you can understand how you have something spinning, and then you play with it, and you can get something really cool. Okay? So, baseball bat, Coca-Cola bottle, pretty much any of these shapes, that's how you do the math behind them. So mechanical engineers, brace yourself. You're going to have more of this. Okay? So what does this look like? Well, if we spin it around the axis, it's going to look like that. Exactly the same upside down. And every cross-section is a circle. You just add up all the cross-sections. Okay? Now, sometimes this is referred to as disks. Sometimes it's referred to as washers. People seem to be confused. They're really the same thing. A disk is just a washer with no hole in it. Okay? So if you wanted to find the volume, it's going to be pi, and you're going to do the integral from 0 to 9. Okay, the top curve squared, so that's 9x minus x squared minus the bottom curve. Well, the bottom curve is just 0. Minus 0 squared dx. Okay, because the top curve is y equals 9x minus x squared. The bottom curve is the x-axis. Okay, this is the bottom. This line, not this dotted line. That's just the image when it goes around. Okay? So the bottom curve, the inside curve, is just the x-axis, which is x equals 0. Okay? Versteh? Capish? Wakarimasu? Yes? Okay, so we can integrate that very easily. Foil it out, you get 81x squared minus 18x cubed plus x to the 4th dx, because you guys can all foil. Maybe some faster than others. Okay. That is 81x cubed over 3 minus 18x to the 4th over 4 plus x to the 5 over 5 from 0 to 9. I would never ask you to plug 9 in. It's 9 to the 5th is kind of a big number to work out in your head. Okay? Sorry? Oh, and then, right, well, okay, and after multiply this by pi. Sorry. Good thing I brought you. Okay? We might just ask you to set these up. We might not ask you to actually do the integrals. We might ask you to do the integrals. It depends on our mood. Okay? These integrals can be algebraically difficult. Of course, if you go from 0 to 1, it's not so bad. But 0 to 9, as I said, 9 to the 5th is a big number. It's the same size as 3 to the 10th, which is a lot. Okay? So far, so good. Does everybody understand what I did? Let's do some more of these, because I believe that you get good at them by doing several of them. Let's pick across an example or two. Okay. Okay. Let's say we were going to do the region between y equals x squared and y equals x. Y equals x is just a straight line. We're pretty much just going to stick with the first quadrant, unless we tell you otherwise. Okay, we'll make sure you can understand what the region is. Y equals x squared looks like that, so we're looking for that region. Okay, this is the line y equals x, and underneath is the parabola y equals x squared. We're going to spin that around, so when it goes around, you get something that looks like that. So every slice looks like that. And then you add them up. Kind of looks like the bell of a trumpet, maybe. It's hard to describe how that looks like. A speaker. Okay? Not a headphone, a speaker. Okay, where do they intersect? They obviously intersect at x equals 0. Anywhere else? Well, you just said x squared equal to x. Right? That's where those points equal. So x squared equals x. X squared minus x equals 0. That's x times x minus 1 equals 0. So they can intersect at 0, 0, and 1, 1. So again, if you want to find the intersections, which we may give you, we may not give you, if you want to find where they intersect, you have to set the curves equal to each other. And then the volume is pi. You need to go from 0 to 1. The top curve squared minus the bottom curve squared. Yes? How would you determine which one's the top and which one's the bottom? You go to the x-axis. The first curve you hit is going to be the inner radius. And the second curve you hit is going to be the outer radius. Okay? So top minus bottom. Some of these pictures, as I said, the top and the bottom will switch each other. Okay? So that's pi. You need to go from 0 to 1. X squared minus x to the 4th dx. I would have no trouble expecting you to do this all the way out. So that's pi times x cubed over 3 minus x to the 5th over 5 from 0 to 1, which is pi times 1/3 minus 1/5, or 2 pi over 15, because when you plug in 0, this is just 0. How are we doing? Totally lost. Where are we lost? Okay, so how do you do these? First, you have to draw a picture. Makes your life easier. You want to find where they intersect, then you're going to integrate from the left side of the intersection to the right side of the intersection. Okay, so in this case from 0 to 1. You would take the top curve x and square it, minus the bottom curve x squared and square it, times pi. So the integral of x squared is just x cubed over 3, and the integral of x to the 4th is x to the 5th over 5. You plug in 1, you plug in 0, you subtract. Let's give everybody one to work on, because we know how much fun these are. Okay? Why don't you try that? Nice, straightforward graph. Let's see if you guys can find the volume. You can take the region between y equals x squared plus 4 and y equals x plus 5, revolve that around the x-axis, find the volume.
Only sport that matters. There are other sports that matter one day. Long Island is the most. Cheers. You doing okay here? It was all like yearly. Good.
Other stuff in the last It's a skill. I hope you're coming there.
Okay, you let me know. 8:30? Yeah, pick you up. 8:30.
You can bring Olin if you want.
Nah, we don't like Olin.
Don't bring Olin. You can bring Timon. Timon's always okay. Or you can bring Nia. She's adorable. You guys have matching nose. That could prove very, very humorous. Right? You get stuck to get satisfied. Right, yeah.
What are you talking about? First time you see it. Yeah, and you don't come.
See, this is the miracle of video. So we could just fix it. Just make it x plus 6 instead of x plus 5. And then it's easy to factor.
Oh my god.
Sorry.
No, it doesn't. Does it? It does. No, no, plus 2. It's 2.
There you go. I mean, you can do it with 5. You get 5. You get the golden ratio number. 1 plus the square root of 5 over 2. 1 minus the square root.
Two papers shut off. It's like 2.
No, it's 2.
What is it? What are you saying?
I just said that what that is.
We're doing 6 plus 6.
We'll get going on this. But first, drew that a little off center. Okay, that's y equals x squared plus 4. Y equals x plus 6. you want to find where they intersect, you get x squared minus x minus 2 equals 0. And that's x minus 2, x plus 1. So this is negative 1, and this is 2. Okay? Is that right? So if you were going to revolve that, then this will go around the axis, and you would get a shape roughly like that. As I said, I'm a terrible artist. Okay? It doesn't really matter what it looks like. You don't have to be able to draw what this three-dimensional shape looks like. The key is that, yes, OD. How do you know which one is on top? Well, when you graph them, you should be able to tell. If you're not sure, you pick a number between the intersection points. So 0, and you say which one gives you a bigger value. You plug 0 into x plus 6, you get 6. You plug into x squared plus 4, you only get 4. That tells you that the line is above the circle, the parabola. Yes? Well, you have to know what y equals x squared plus 4 looks like. You have to know that's a parabola. Okay? Parabola centered on the y axis. Okay? Shifted up 4 from the origin. You should practice drawing these. Okay? So then the top curve is going to be x plus 6. The bottom square curve is going to be x squared plus 4. I heard somebody saying something. Questions? So the top curve squared minus the bottom curve squared dx. So that's messy, but not ridiculously. That's equal to pi. Integral from, not from 0 to 1. Integral from negative 1 to 2. How do I go? No, I'm going from negative 1 to 2. I'm going from x equals negative 1 to x equals 2. That's where I'm integrating, right? I'm slicing here, and I'm going to add up those slices. So x plus 6 squared is x squared plus 12x plus 36 minus x squared plus 4 squared is x to the 4th plus 8x squared plus 16 dx. So remember when you were in algebra class and you said, when am I ever going to need this stuff? Now. This is when you need this stuff. This is why copying off your best friend wasn't the best solution, although it worked just fine in the 8th grade. So if we simplify that, you get minus x to the 4th minus 7x squared plus 20. Is that what other people got? Guys, is that right? I don't know. Oh, that's plus 12x. I apologize. That's not 12x squared. See? That's minus 8x squared plus 12x plus 20. Right? No. X squared minus 6 minus 7x squared. Thank you. Got it. Oh, you get old. You're lucky you're wearing your pants. Okay. dx. Alright, can we integrate that? Oh, sure. I'm going to come over here. That's pi times minus x to the 5th over 5 minus 7x cubed over 3 plus 6x squared plus 20x from negative 1 to 2. So far, so good? Then you got to plug in 2 and -1 and figure out what that is. It's really annoying, so I'm not going to. If I were testing this, I would say when you get to this step, you can stop. Okay? When I teach this, when I'm in charge, I'm not in charge. When I'm in charge, I think that's good enough. Okay? Because after that, the arithmetic gets a little messy. Okay? Although I have faith that you could do it. Because you guys are in 126. Alright, should we practice another one? Then we move on to other types of volumes. Okay, this time our region is y equals x cubed, between y equals x cubed and y equals the square root of x. And I'm in the first quadrant, just in case there's any confusion. I'm going to spin that around the x-axis. Okay?
No, there are.
There are definitely
Yeah, it's really good. But how does that That's.
I'm just trying to figure out. So I want to finish our file is here, which is +1, 2, they intersect again, which is 2. This is
Those of you who are graph impaired, y equals x cubed looks about like that. Y equals the square root of x.
that's why it's wrong.
It's not like that.
You did good. That makes
I said that. 0. We're going to put down a 0. And there's another one here. Because there's another number that needs to equal. Okay, so you can just set them equal. Probably going to do. Or you can set up your numbers in. So we'll start with 1.
No, I don't like that.
The answer is 1. So what's 1 cubed? 1. So they need to be 0.
Go on this board, please. There's lots of buzz, so I assume that means we're ready. Okay, so that's our region. So you guys should get comfortable with what these graphs look like. I think I'll take a minute and go over graphing before we go on. So y equals x cubed is this graph, and y equals the square root of x is that graph. So that's our region. We're going to spin that around the axis. And each of the cross sections will look like that. So the volume is going to be pi, top curve squared, minus the bottom curve squared dx. Now, you just have to find where they intersect. Well, if you're comfortable with the graphing, they obviously intersect at 0 and 1. Or you can set x cubed equal to the square root of x, square both sides, and solve it from there. Okay? Once you square both sides, it should be fairly easy to solve. You get x to the 6th minus x equals 0. Pull out an x. You get x equals 0 or 1. So that's 1, 1. That's the origin. So you're going to integrate from 0 to 1. Okay, so that's pi. Integral from 0 to 1 of x minus x to the 6th dx. So that is pi times x squared over 2 minus x to the 7th over 7 from 0 to 1, which is pi times a half minus a 7th minus 0 minus 0. which is 5 pi over 14. You guys, I showed you how to do the fractions, right? I showed you that earlier in the course, right? If you want to do a half minus a seventh, you do 7 minus 2 over 7 times 2, right? Okay? So make sure you can handle these fractions. But if you can't, set it up all the way to where you plug in the arithmetic. Okay? That way you won't have a trouble in the last step. So far, so good? Alright, so I'm going to take a detour for a minute, a digression. Just make sure everybody can graph. So, because, there's families of graphs you want to make sure you're comfortable with as we do these. This is something I usually do for the first day of 125, but I might as well go over this. So I'm going to erase this, okay? Everybody set to erase? Say goodbye. Okay. Y equals X. Straight line through the origin. 45 degrees. There's no name of this topic. This is just review of basic graphing. But I can call it, how about that for a name? Alright. Y equals X squared is a parabola through the origin. Okay? So if I give you y equals x squared plus 1, you just shift it up 1. If I give you y equals 10 minus x squared, you turn it upside down and then shift it up 10. Right? So 10 minus x squared goes somewhere over there. Okay? Y equals x cubed looks something like that. So far, so good. Y equals the square root of x. Looks like that. Alright, so let's see. Y equals 1 over x. We'll usually only ask about the first quadrant part of the graph, but you never know. Y equals 1 over x gets interesting because there's that vertical asymptote in the middle, right? So if it was y equals 1 over x minus 2, you move it 2 to the right. If it was y equals 1 over x plus 2, you move it 2 to the left. Okay? If you had y equals 1 plus 1 over x, you move it up 1, down 1, left, right. You should be able to do all of those, okay? So far, so good? Some other basic ones. Y equals sine x. That's a pi, 2 pi, 1, negative 1. What else? Cosine x? That's pi, so that's pi over 2. That's 1. That's negative 1. That's 2 pi. And so on. 2 more.
Party next door posted a picture.
So far, so good? So you should review these. Make sure you do the simple graphs. We're not going to give you anything too crazy. You can't integrate it. That's the other thing. When it's done, you have to be able to do the integral, or you just have to set it up. Y equals e to the x. Looks like that. Goes through the point 0, comma 1. Y equals natural log of x. Goes through 1 comma 0 because it's the inverse of e to the x. Am I forgetting anything? I don't think so. I mean, we're not going to have you graph inverse sine. That kind of stuff. Of course you could if you wanted to, but we're not going to have you do that. Yes? You want to know what tangent looks like? Tangent looks a lot like the cubic graph. But sure, if we were feeling really nasty, we can give you a tangent graph.
Really close to that. He's Canadian, making no chill.
That's terrible. So they kind of look like cubic graphs, but they have vertical asymptotes. Okay? And that's what the tangent of x looks like. Probably enough. Goes through the origin. So we have to, if we're going to do this, we have to give you something to do it with it. Remember, you're squaring and stuff, so we can't give you anything too messy. Okay, so if we give you y equals log of x, and you square it, you have to be able to integrate log of x squared. Okay? Which is not an obvious integral. Okay? So you should make sure you get comfortable with some of these basic graphs. Now, of course, how can we make this harder? Well, instead of doing y in terms of x, we could have x in terms of y. That's always entertaining. Suppose I want to take the region between x equals y squared and x equals 2y and revolve that about the y-axis. First, you have to figure out what that looks like. Now we know what y equals x squared looks like. So x equals y squared is going to do the same thing, except you can turn it sideways. So it's going to be a parabola like that. And x equals 2y, well, if you divide by 2, is the same as the line y equals x over 2. So it's just going to kind of go like that. It's actually a little flatter. So this is our region. But now we're going around the y-axis, not around the x-axis. So that's what our rotated region looks like. So if we want to do our washers, okay, they're going to be with horizontal slices. So as we saw on Wednesday, it's just the same thing as when you're doing the vertical slices, except everything's in terms of y. And if you want to find the radius, you're going to take the outside curve minus the inside curve. So the outside is this line x equals 2y, and the inside is x equals y squared. How do I know that? Well, you pick a y and see which one gives you a bigger x. Okay? But you imagine you're here, you go out to the line is farther than going to the curve. So the volume is going to be pi, outside curve squared minus inside curve squared dy. Now we just have to find where they intersect. And they intersect where y squared equals 2y. So you subtract 2y from both sides and factor out the y. Okay, and you get y equals 0 or 2. And you check, plug 2 into both equations and get 4. So they intersect at 4, 2. But we're going to be slicing horizontally, so you want to go from 0 to 2. You want to do the y values, not the x values. So that's going to be the integral from 0 to 2, pi, 4y to the 4y squared minus y to the fourth dy, which is pi times 4y cubed over 3 minus y to the fifth over 5 from 0 to 2. Notice when you plug in 0, you're going to get 0. So we just care what happens when you plug in 2. And that's going to be pi times 32 thirds minus 32 fifths, which is 64 pi over 15. Okay? There's a trick to that. Did we hate that one? We didn't hate that one. Really? I would have hated that if I were you guys. You want to try one? Let's give you one to try.
Has it on the coffee?
Let's see. Okay, let's take the region between x equals y cubed and x equals y. In the first quadrant, and we're going to go about the y-axis. Okay? This is bigger than the outside. The integral. And whichever one is the bigger one is going to go first. We good? Ready? We good?
You'll let me know about tonight. You bring it tomorrow? Okay. It's enough? You don't need to bring more.
We're going to Carnival or the other place?
No, we're going to a new place, Ragazzi.
Where's that?
Near the mall. It's going to be Michelle,
I
Marissa.
saw a place when I was driving on 347. It's called Carrabba's. You ever been there?
Yeah, it's not bad.
Girl. I just saw it. I was like, never been there.
Yeah, they do a lot of catering for the games. And the
really?
events, yeah. They're not bad. I don't think it's worthy of Nia.
Excellent.
Yeah. How's the drama on the table?
Sufficient.
Reasonably dramatic. Well, I know we're losing 2 people. Anybody
Yes,
else?
that's the plan.
Anybody else?
I don't think there's
You don't think Kara's going to stay? I've seen him.
Stuff just anything.
Do you think Kara's going to leave?
I mean, I wouldn't be surprised.
She doesn't seem very happy yet.
Yeah, no, like her suite mates for next semester are all like on athletic classes. Like I'm not even seeing her.
Why not have that? I like Kara. Is she good? No, it's Kara.
Yeah, you're close to stuff.
Nice girl. Kara's good soccer player. Girl?
I know none of them.
You don't know any of them. We got to get you out.
I do go out. I just.
Can't go out anymore.
I've been an introvert lately.
Yeah.
Me will be like,
You need to know.
Don't talk anymore.
That's that video. You got that.
put it on secret.
No. But now everyone knows. So we'll just take that little clip and put it on Insta.
Just play it over and over.
How are we doing this? Good? You loving this? Otherwise,
Who is it? Who?
all right?
The only reason I'm not mad is because this party next door. I'm mad.
So x equals y is the same as y equals x. And if y equals x cubed goes this way, then x equals y cubed is going to go that way. So as long as we're in the first quadrant, we only have to do this region. Now, if we were not just doing the first quadrant, you'd have to find both intersections. You'd have to do 2 integrals. Okay? You'd have to do the integral of what's here in quadrant 3, and you have the integral of what's in quadrant 1. But we only care about the part in quadrant 1. That's why I wrote that. Did you all find if you intersected 0 and 1? Okay? So we do pi, the integral from 0 to 1, the outside curve squared minus the inside curve squared. Now if you're not sure which one is the outside curve, pick a number between 0 and 1, like a half, and see which one gives you a bigger value. So when y is a half, x is a half, x is an eighth. So since x is a half at x equals y, that's going to be the outside curve. So that's going to go in front. So it's going to be y squared minus y cubed squared. Now, what happens if you get it backwards? You'll just get the negative answer. Okay? So if you get negative something, then you just probably did it backwards and changed it from negative to positive. So this is going to be pi, integral from 0 to 1, y squared minus y to the 6th dy, which is pi, times y cubed over 3, minus y to the 7th over 7, 0 to 1, which is 4 pi over 21. Right? Positive. If you get negative 4 pi over 21, you had them backward. Okay? How do we feel about these? Starting to get the hang of it? Now, of course, how do we make it harder? Well, we don't go about the x-axis or y-axis. You can go about a line other than the x-axis or the y-axis. I'm not sure if we're covering those. The other is you could slice the other way, which is what we're going to do on Wednesday. I have to check with the professor about what else we're going to do. Yes? You have to come and ask me. I can't hear you. All right. What? Explain to why the y is on top. When you plug in a value for x, for y, okay, between 0 and 1, this number is bigger than this number. So that's why it's on the right minus the left. Okay?
Can't trust dots.
Girl, what's your name? What's your name, girl? No, not you. I got a little bit. What's your girl? Yes, she is. Yes, she is. What's your girl?
I've done most of them. I haven't taken one yet. Well, I'm asking
Watch out. There he is. That's my neighbor, y'all. Whatever it's yo, friend! He don't hear me, but it's cool. That's my homie. Come on. Legendary. That's what he is. Legendary. That's alright. Spitting games.